Good afternoon. Welcome to session ANT330. Just a gentle reminder, this is a silent session, so we may not be able to answer your question during the session. But after the session, we'll be available next to the podium for almost 10 to 15 minutes to answer any of your questions. You can also meet us in our expo in analytical booth as well. So let's quickly talk about the one scenario before we start the session. Imagine that there is a fire in a house, and next to that house, there is a big water hydrant, which is capable of sending thousands of gallons of water in a matter of minutes. Now I just went there with a trusted spanner and I opened the cap of the water hydrant and I let the water flow. Can I see raise of hands if you see that this approach will help for me to extinguish the fire? Not a single hands up. That's right. This will not work. Now let me make a small change in that. Instead of just going with the spanner, I got a pipe where I ingest the water and directed the water to a fire. Now can I see a raise of hands if this approach may work to extinguish the fire? A lot of hands. Thank you for showing such a great confidence in me. But yes, this approach may work because now I'm able to ingest the water and direct to the right place. We observe the same challenges with our customers, where they have a lot of variety of data, but without having a good, clear ingestion strategy, they struggle to meet their business outcomes. That's why we're going to talk about some of the strategies when it comes to different use cases while ingesting the data on AWS. Before I start, let me introduce myself. My name is Rahul Sonavne. I'm a principal solutions architect based out of Atlanta, Georgia, and my area of specialty is analytics and AI/ML. I'm here with one of my colleagues, Chinmay. I will let her introduce.
Hi everyone, good afternoon. My name is Chinmay Narasimhadevara. I'm a senior solutions architect with AWS and I focus primarily on analytics use cases. So great to see you all here.
Thank you. So to start with, we're going to talk about some of the change in the data ingestion landscape over a period of time, especially concentrating on our modern data architecture strategies. We will follow by some of our data ingestion use cases, especially targeting our target systems where your business partners or your consumers can read the data from. At the end, we will talk about some of the common architectures and some of the key strategies that we can impose to make it effective use of the data ingestion and make your businesses become more agile to get the data as soon as possible. This is one of the common diagrams. I think you must have already seen this diagram. So can I see a raise of hands if you already seen this diagram or use this as a part of your design? Bunch of us. Thank you for that. Again, yes, this diagram is so popular because it simply works. It gives you a scalable storage with unified governance around all your data end-to-end platform. But today's session will be focusing on one of the key pillars of it, which is nothing but seamless data ingestion. The whole session will be talking about different ingestion strategies across different tools and services as well. So when we talk about ingestion strategy, especially concentrating on this diagram, there are three patterns emerges. The pattern one, which is nothing but your data is getting ingested from your logically centralized location, it's represented as data lake here, to your purpose-built data stores. In that case, data warehouses, or coming to machine learning application, or maybe log analytics as well. That we call as an inside-out pattern. There's another pattern emerges, where your business partners working in this specialized areas and generated the new data set. And they are willing to share the data to the centralized location again. That becomes outside in pattern, where let's say, for example, data coming from relational databases, maybe OLTP system, wants to share the data with your centralized hub as well. But at the same time, there's a third very important pattern comes in, where as a users, they would like to talk to each other for the common goal for a business. And that time, they would like to share the data or maybe able to physically transfer the data elsewhere in some cases to meet the common business goal. That's where the around the perimeter pattern comes in picture. We will dive deeper into some of these patterns and some of these use cases, how we can leverage different AWS services to make it happen. When we talk about different patterns now, let's look at some of the challenges which arise. Looking at so many different units, different source systems, looking at like relational databases, I talked about data lake. These are heterogeneous systems. Combining it together, it's sometimes challenge because your consumer might be expecting data in certain fashion or certain format to make it easy for them. That involves sometimes creation of ETL jobs. Drawback of that, it adds the slowness in the process to make the data available for your downstream applications to read from. Side effect of that, your business partners might start creating their own data sets because they have certain business needs to complete. Drawback of that, it creates data silos. And eventually you will face the challenges where you cannot trust a single version of truth of a data. Now to overcome that, that's why we were thinking about some of the key strategies and how we can impose them to your architecture to make it flexible as well as cost effective. So I try to categorize our ingestion pattern in few important characteristics. The first characteristics is based on the sources. Now when you look at the different sources, and especially into heterogeneous systems, there are a lot of different sources systems like databases coming from relational databases, where it is mainly more towards structured data. So I'm going to start bridging the gap between some of these characteristics now. So you'll see data coming from relational databases, mainly into table, row format, which has a set structure. The data coming from files, based on where it's coming from, it might be semi-structured or it can be unstructured as well. But when you talk about SaaS applications or talk about IoT devices, where they are sending real-time data, the structure can be variable. It can be sometimes structured, semi-structured, or unstructured as well. So if you observe, I'm talking about source structures, but at the same time, I start going into another category of data types as well. So that's where structure, semi-structure more towards JSON file formats comes in picture. But looking at recent enhancements into the Gen AI side, there is unstructured data is also become very important for businesses to tap into, to find the important insights from it. That's where unstructured data is also becomes one of the key aspects to consider when you are ingesting the data. Let's talk about when the data is arriving. So based on that, it gets categorized as batch process. It can be batch or micro batches as well, where the job is running at particular time based on the push model most of the time, or the pull model as well, to get the data into your ingestion location. But at the same time, the devices which are able to send the real-time data, or maybe your web applications, which are sending the data at near real-time, fall under the streaming applications. At the end of it, all this ingestion data comes to a target systems which get consumed by your downstream applications. So in the consecutive slides, I will start diving our approach of data ingestion based on the target systems. We call it as a working backward approach. So very first system I'm going to talk about it is ingestion into data warehouse. Again, very old concept. 25 years ago when I started my career, my first job was working on a data warehouse. So can I see raise of hands if you already worked on data warehouse or using data warehouse or planning to use warehouse? A lot of us. Thank you for that. Thank you. If I try to put the definition to a data warehouse, simplistically it is a highly efficient data hub which can store historical data to allow business analysts to do the trend analysis or historical analysis as well. But the trends start changing a bit now. It's not just tailored reports or analysis versus now business expect them to do ad hoc analysis as well. That's where we have a service called Amazon Redshift, which is fully managed AI-powered cloud warehouse, which has your storage and compute as scale independent of each other. We do provide cluster as well as server option in that area. So let's start using Redshift as our target system and see what are the different ingestion pattern comes in picture. Before I dive further deeper into it, I'm going to introduce another concept called zero ETL. I'm going to use this multiple times during my slides as well. So first of all, what is zero ETL? So zero ETL is meant for point-to-point data movement where as a user, you do not need to create ETL pipelines. Before zero ETL, you will creating a pipeline, tapping into your sources, extracting the data, then loading to your target system. Then eventually you will have to orchestrate the whole job and start based on either a batch or some triggers as well. Now with zero ETL, as a user, you do not need to worry about creation of those pipelines anymore. You will just need to configure your source and target. You have options to even select which objects to transfer. That point onwards, AWS will make use of effective resources and cost to transfer the data effectively. It will automatically scale up and down based on your user, based on the data needs as well. Benefit of that, Now, because of which now the data will be available in your target system quickly enough. At the same time, it is giving unified data at the same time in the data warehouse in our case, and which will help the user to get the analysis done and find the insights across multiple systems. So let's dive further deeper into it. How we can make use of zero ETL for loading the data into Redshift. So we started our zero ETL journey last year. Very first, we introduced Amazon Aurora MySQL as a source to load the data into Redshift. That time, we gave the option to transfer the data based on the whole schemas or databases, but we improvised it. Now we have option where you can define which particular tables you want to transfer based on include and exclude option as well. Our customer really liked it, mainly especially when looking at their OLTP system integration data warehouse at near real time. This plays a vital role. They're able to transfer the data at near real time without adding additional overhead on the OLTP systems. They asked for furthermore. They're like, can we integrate some more services? That's what we integrated with Amazon Aurora PostgreSQL as well as RDS MySQL and recently DynamoDB as well. So these are all the third-party services at this moment can be integrated in Redshift using zero ETL. But we understand, when you talk about warehouses, it's not only AWS services. There are a lot of applications which are also sending the data. That's where we enhanced zero ETL to integrate with third-party applications like Salesforce, Zendesk, ServiceNow, just to name the few. Now, as a user, you can use same power of zero ETL to integrate the data from third-party applications and your first-party applications coming from different data sources and combine them together as a part of Redshift. Once the data comes in Redshift, you can use SQL language to manipulate or find the insights of the data as well. Let me move to another approach. Now imagine that you have an online transactional system or let's say point of sale system, which is capable of sending the real-time data to your warehouse applications. And now your business partners are looking for an approach where they can mix together your real-time data with your warehouse data. It's more towards near real-time data warehouse. In that case, we have option to integrate the data coming from streaming applications like Kinesis data stream or Kafka. I'm representing it as a MSK here, to directly ingest the data into your Redshift. Redshift has the ability to ingest the data directly from your streaming application. In our example, it can be point of sales terminals, which are continuously sending the data through streaming ingestion, and that data without any hop can directly arrive into your warehouse. Once it arrives into warehouse, it behaves more like materialized view. So data ownership has been shifted to warehouse, and now as a user, get the ability to combine already available data with this streaming data as well for the analysis. Very good pattern when you have requirement related to near real-time data warehouse and joining the data with existing historical data as well. Now let's look at the other patterns. Till now I talked about almost near real-time and configurable, but we understand there are options where your vendor might be sending files to you and those files are landing on S3. Or you might have ETL jobs, which is processing the data and landing a file on S3. Before you're introducing this feature, user needs to write a copy command in Redshift, and you have to orchestrate it, which will copy the data from the file into a Redshift table. With auto copy feature, as a user, you do not need to worry about orchestrating the job anymore. In the beginning, you will just configure a copy command once. Once it configured, that point onwards, Redshift will take the responsibility of transferring the data from the files into tables by itself. Whenever the file arrives, it will internally understand file or multiple files are arrived. It will create corresponding manifest file and transfer the data effectively into your Redshift warehouse. This is another important aspect where we can get the access to now your streaming data, your near real-time data, and batch data together. So those patterns I talked about. But still we understand there are some other patterns also applies. For example, I need to get the data from my on-premises databases and load it in my warehouse. That's where the service like DMS shines, where it has ability to read the data from your source systems, maybe the relational databases, and transfer the data into Redshift. But at the same time, there might be possibility you might have a need to cleanse the data, might need to process the data, join multiple data sets together. That time the patterns related to ETL comes in picture, where AWS Glue or services, third-party services like Informatica or DBT also works as an ingestion pattern. So combine it together. The idea here is getting the data into your warehouse as soon as possible and giving the ability for business users to have a centralized, single version of truth to do their analysis and find the insights. Now I'm going to change the gears. Now I'm going to talk about data lakes. Again, before I start, can I see raise of hands if you're already familiar with data lake or use data lake in certain fashion? Almost all of us. Thank you for that. Again, data lake is quite famous because it gives the flexibility to have a scalable storage with corresponding cataloging when it comes to storing the data or ingesting the data. But at the same time, it gives the flexibility for the consumers to bring their own choice of compute and interact with the data. But when you start talking about consumers, the consumers comes with their own needs, or to make it effective, they might need a data in Parquet files, which is columnar, or they might need Avro files or CSV files. Effective partitioning mechanism to make it ingestion or as well as data execution more effective. Now let's put it together. Our source systems, yes, when you talk about data lakes as well, we have heterogeneous source systems coming from a lot of different areas related to SQL, SQL, NoSQL databases, real-time data, third-party data, API data, multiple of those. But based on the frequency, we can create two separate categorization here. The first one is your batch layer, where data is coming at certain intervals. It may be once in a day, once in a week, or twice in a day, or maybe if you want to go for micro batches, maybe every 15 minutes as well. The other category is more towards streaming ingestion, where your sources are sending real-time data and that data needs to land in data lake as soon as possible. There are some of the key services that I'm going to walk you through, how we can use them effectively during this different ingestion patterns. Once the data is available in data lake, as I was previously talking about, it gives the flexibility for your consumers to bring their own choice of compute. Your consumers can be from AI/ML side, where they want to use SageMaker or Bedrock for their analysis. They can be coming from ad hoc processing, like a query tool like Athena, which background use Trino engine to run the queries, or maybe using QuickSight for their visual representation of the data as well. So in that area, you must have observed AWS Glue is present in batch as well as in real-time streaming as well. So let me quickly walk you through what AWS Glue offers when it comes to ingestion. Again, in the broader spectrum, AWS Glue is a serverless data ingestion, discovery, preparation. It also has data quality rules implementation as well as it has capability to create data catalog. But in my session, I'm not going to go through all of it. That will take almost an hour just for Glue. So my main focus will be on ingestion patterns. So when it comes to ingestion from heterogeneous multiple system, AWS Glue provides multiple different connectors. Now those connectors can be connected to your databases, can be connected to your streaming applications as well. We have providing out of box 70 plus different connectors. But we understand that when you talk about source systems, there are so many source systems that we may not have connectors for. That's where we give the flexibility that as a user, you can bring your own connector. And that bring your own connector can be from marketplace, because many of our partners has already multiple connectors available through marketplace, or you can get your custom connectors as well. Good part is when you use these custom connectors, AWS Glue will automatically incorporate it at the time of execution without any additional cost. If you're taking the connector from marketplace, there might be a cost from the vendor side, but AWS Glue do not add that cost. Now imagine our use case where I need to get the data at certain time interval from a database and I want to put it in my data lake in a Parquet file format. That's where I can make use of JDBC connections available as a part of connector library. It can be coming from MySQL or can be coming from other databases as well. But at the same time, because as Glue has capability to do real-time ingestion as well, it has connectors connecting to MSK as well as Kinesis as well, where your job is always running, it never ends. It we call it the continuously running jobs. Now these job gives you ability to define its own hardware. Both the type of job gives you the ability to define your own hardware, and it's capable of scaling up and down based on the data flow. We'll dive deeper into some of those strategies in some consecutive slides, but at this moment, I'm going to define that it has a capability to ingest the data at near real time with the continuously running jobs. And it has a capability to read the data and ingest into data lake at particular time interval in a batch mode too. Talking about next service, again, this is more towards, imagine you have a marketing campaign going on and you have clickstream data that you want to ingest. That time the requirement is I need to get the data as soon as possible into my target system because that's very sensitive data. That time, one of our services, Amazon Kinesis Data Streams, comes in picture, which is again fully managed, massively scalable, and gives you option to scale based on your data needs. It gives you option for provision as well as serverless capacity. In that case, in the provision, you have option to define the number of shards. Now, shard is a mechanism by which you define your throughput. Number of shards is directly connected with your throughput when it comes to how many records are ingested as well as egress capacity as well. We'll dive deeper into some of those patterns as we go further in the discussion. But some of my customers are able to transfer multiple GB of data. Actually, one of my customers is transferring 2 GB of data per second just by using the shards. But now it also gives you ability that if you do not want to do the calculation about shards, so that time you can use on-demand capacity, where we will take over the responsibility to add and remove the shards based on your data needs, which makes it very flexible for you to ingest the data as soon as possible. There is another service which has similar features, which is related to Apache Kafka. Again, Kafka is another very famous open source application available. Can I see raise of hands if you have experience with Kafka, used Kafka previously? No surprises there, so many of us. Thank you for that. And again, if you're familiar with Kafka, the main pain point is managing the hardware, making it available, highly available all the time, making sure it is disaster recovery is handled, it is making sure it gives continuous responses without latency. That's where we introduce service which Amazon MSK, where we take care of the responsibility of complete hardware maintenance for you. It is fully managed, so we have to make sure that it's highly available, durable service. This service also provides you two different options. One is provision capacity, and you can easily guess the other one is serverless, where we have option to pay as you go model and still meet your requirements when it comes to real-time data ingestion. Now, both these services are capable of sending the data to your data lakes or multiple target systems as well. Let me change the gears a bit now. So till now I was talking about real-time data ingestion, but I never talked about the format. And when I talk about in the beginning as a data lake, I was talking like I want the data in Parquet format or CSV format with high partitions. How to achieve that? That's where Amazon Firehose service comes in picture. Firehose has an option to ingest the data from multiple source systems. MSK, Kinesis is just some of them, and capable of sending the data to multiple target systems in certain fashion or certain formats. It is capable of creation of dynamic partitions as well. So when I send the data on S3, I do have option to create the partition on hourly basis. Very useful, and many of our customers use this when they want to ingest the security logs or get the information across their multiple systems to club it together on hourly basis. It has integration, once you create the data in partition, it has integration with multiple other compute services where you can start analyzing the data quickly. So that's where now we can see the spectrum where I have ability to quickly ingest the data in the format where it's already available. I have ability to transfer the data into a format which might be effective for my downstream applications. Combining it together, it gives you the whole lay of land when it comes to data lake. Now let's take a pause and let's look at from the business perspective. Till now I talk about I have a warehouse, I have a data lake. Now from a business, they really don't care. For them, the main thing is give me a central unified data store where I can run my queries. I don't need to worry about whether it's coming from your warehouse, which is a columnar warehouse with tables, or whether it's coming from file system, which might be Parquet files with partitions in there. Their main aim is give me a centralized location where I can go ahead and run my queries. That's where we start introducing, which must have heard me in keynotes, which is nothing but Lakehouse approach. Lakehouse approach bridge the gap between your data warehouse and your data lakes. As you must have heard in our keynotes, we introduced Amazon SageMaker Lakehouse, which is capable of integrating the data across your data warehouse, across your data lakes, across your operational data sources, as well as different applications as well. As an end user, you do not need to worry about whether the data ingestion or data is coming from data warehouse or a data lake. But our main talk is related to ingestion patterns. So now let's talk about how we'll be able to ingest the data into this SageMaker Lakehouse. That's where I'm going to go back to the discussion about zero ETL. So just the way which I talked about zero ETL integration with Redshift, we have similar approach available with zero ETL integration with SageMaker Lakehouse, where you can get the data from first-party sources like DynamoDB, PostgreSQL, MySQL, Aurora, as well as RDS as well. But at the same time, ingestion with other applications like Salesforce, SAP, ServiceNow, those are also available. At the end of it, zero ETL will be able to transfer the data at near real time, again depending on which sources you're looking at. That's what one of the caution you need to go and observe about the latency involved, and get it transferred into a centralized place, which is nothing but Amazon SageMaker Lakehouse. So we talk about specific to AWS services and zero ETL. But we understand, as a user, you may not be just directly want to use zero ETL. You might have your own applications, or you might have your own approach to ingest the data. Now, how this SageMaker Lakehouse will fit into that area? That's where we are exposing SageMaker Lakehouse through Apache Iceberg Open APIs. One of the options which you must have heard is related to using Amazon SageMaker Unified Studio, which is available now, that we can interact with SageMaker Lakehouse. You can make use of Unified Studio to ingest the data into your Lakehouse by directly the connectors available inside the studio itself. But if you have your own custom application, so imagine you're writing a job using Jupyter Notebook, or you have certain application which is running on AWS Glue, we still support that as well. Based on the recent announcements, especially in Glue 5.0, we have direct integration using SageMaker Lakehouse as well, where as a user, you can use AWS Glue service to ingest the data into Lakehouse as well. If you are using any third-party tools, as long as those third-party tools are able to interact with Apache Iceberg Open APIs, you can use that to ingest the data in Lakehouse or Lakehouse style as well. So putting it together, now I talked about Lakehouse and everything to get it all the data at centralized place. But we understand there are many different systems or many different companies already start adopting different open table formats. So can I see raise of a hand if you already start using open table formats, thinking about it, or have some experimental done? Bunch of us. Thank you for that. Again, open table formats are very popular because it gives you flexibility to do ACID transaction on S3. Even we talked about Lakehouse and we talked about Apache Iceberg, specifically APIs as well. But we do support Apache Hudi, Apache Iceberg, and data lake formats for our modern data lakes as well. The tools which I talked about, especially AWS Glue or EMR, those are capable of ingesting the data as well as processing data effectively for these open table formats as well. So we're going to change the gears and we're going to talk about ingestion data into log and services, and I will invite Chinmay for that. Thank you.
Now let's talk about how to ingest into analytics and search engines. So in AWS, Amazon OpenSearch Service is the search and analytics engine. How many of you are familiar with OpenSearch? That's a good number of us. Thank you. So Amazon OpenSearch is a scalable, secure service that can be used both for analytics as well as for search use cases. In terms of analytics, it supports use cases like log and security analytics, where you can troubleshoot your application, track application performance, get visibility into the system for any kind of issues that you're having for observability, and more. From a search use case perspective, we support text-based searches where it can understand the intent behind, or where it can understand the terms of your query and get the results out. And it also supports semantic and vector searches where it can understand the meaning behind your query, specifically for all those Gen AI use cases that we are seeing. And I know Rahul introduced the concept of zero ETL. We have a number of zero ETL integrations for OpenSearch, so I'll start off with those first. So firstly, the DynamoDB zero ETL integration. Before we talk about how this works, let's understand the why behind it. Taking a customer example. So we have customers who have a lot of data in DynamoDB. This could be like feedback that they're getting from their customers, and they wanted to analyze this data and do some advanced searches on this data so they can actually get more feedback and improve their business. So the logical choice for these searches was to move this to OpenSearch. But it was not as straightforward to get this data into OpenSearch. They first had to enable something called as DynamoDB streams. For those of us who are not familiar with DynamoDB, it's a feature of DynamoDB which tracks any kind of changes, updates, deletes, inserts that happen on the tables, and then you move those tables, you put those data into a stream that can be consumed by downstream. So there's some learning of DynamoDB that needs to happen here. And next, they had to write custom workflows and a Lambda function which would convert it from the DynamoDB format into JSON, which is what OpenSearch expects. So there's some workflow and there's a lot of work that needs to happen. And if there's any requirements that change, this had to be done all over again. So by introducing the zero ETL integration with DynamoDB, we have taken away all that undifferentiated work for you. So with this integration, you can see the data in DynamoDB in near real time without you having to write any code. It is based on Amazon OpenSearch ingestion, and the pipeline takes care of routing, transforming, and aggregating the data, all based on configurations, and it moves the data from DynamoDB into OpenSearch, keeping both the systems in sync for you. In addition to DynamoDB, we also support DocumentDB, which is another native JSON database in AWS. You can use the similar zero ETL ingestion from DocumentDB to keep the system in sync with OpenSearch. Switching gears a little, then we have data in S3. So for DynamoDB and DocumentDB, we were copying the data into OpenSearch. But for this integration, again, let's talk about a customer use case. Like majority of our telco customers, for example, they generate terabytes of data, but they can't ingest all of the data into OpenSearch because it's not economically feasible. So they typically ingest probably like the last 24 hours of data for performing analytics on OpenSearch. But there's a whole slew of data outside, which sometimes is valuable for them to query. So they either have to switch tools sometimes, or they have to ingest a part of the data into OpenSearch to perform these analytics. So to help customers like that, we introduced this direct query integration, where they're able to query the data right from OpenSearch without having to move the data into OpenSearch. The data still sits on S3. In addition to S3, just for this, before this reinvent, we also introduced direct query with CloudWatch logs, which is a log central for everything logs in AWS, as well as for Security Lake, where you can aggregate all of your security data. Again, the ultimate goal here is to be able to get value from this high volume, high value data directly from OpenSearch without having to ingest any of the data into OpenSearch. Let's see a little bit on how this works. So you just first create a data source in the OpenSearch service with any of these integrations that we have, and then you use the dashboard in OpenSearch, which is the UI interface in OpenSearch, and you're able to directly query the data from where it sits directly from OpenSearch. Again, you can use either the SQL or the pipe processing language in OpenSearch to get the data from across different tables. You can combine it with data in OpenSearch or query this data independently. And for Security Lake, we already have some pre-built queries as well as dashboards to get you started off with. And you can improvise on that based on your requirements. And we also have an experience where you can ingest this data into OpenSearch, where like if you have a query that you want really low latency and you want to access the data from OpenSearch, you can ingest just that final result of that query into OpenSearch, so you get a better latency and better experience with that data. And you can also build materialized views, which can have like complex aggregations. And instead of ingesting all that terabytes of data that's out there, you just ingest the result, probably a few kilobytes, and then you are able to power your dashboards and get alerts on that and get all the value from OpenSearch there. To wrap up on OpenSearch ingestion, OpenSearch not only supports these zero ETL integrations, it also supports a number of other sources. It supports S3, HTTP, any of those OpenTelemetric sources, metrics, you can ingest all of those. As well as it supports now streaming services like MSK as well as Kinesis data streams as well as of last week. So OpenSearch ingestion is the recommended way to get data into OpenSearch because it can collect the data, it can transform it for you, and it can buffer it and route the data to the right OpenSearch index. And it provides you a lot of custom transformations as well, both simplistic as well as complex. Like it can do basic transformations where you are able to standardize like a timestamp format or something like that. And it can also give you processors where you can ingest any kind of text data as vector embeddings if you want to use it for your generative AI use cases. Again, it's a completely scalable service. It's completely serverless, so you don't have to worry about scaling it up and down for your traffic or requirements as well. So that wraps up all our ingestion services. Next, I'll go through building out a reference architecture using some of these ingestion services that we talked about for the different target systems. And we want to keep simplicity and high efficiency as our guiding principles as we go through building this architecture. To make it a little more concrete, here I have taken some data sets which are common with our retail use cases. So we have product data, supplier, customer, and order data, which are going into Amazon Aurora as well as DynamoDB in this architecture. And then we have clickstream data, which is flowing into Kinesis data streams. And we have SaaS applications like SAP and Salesforce, which this retailer uses. Then we have a number of data files, all structured, unstructured, as well as semi-structured, across different S3 buckets coming in from various sources. And last but not the least, we have log data, which is coming in from all these applications that this retailer runs. And we'll still focus on the same 4 target systems that we discussed so far: Redshift, Data Lake, S3 Data Lake, Lakehouse, as well as OpenSearch. And I'll start filling out the data ingestion layer in the middle with some services. And I'll also talk about some key strategies that you can use for each of those services to build a well-architected system. I also wanted to call out, like, I have chosen Aurora here, but you could have RDS, or instead of Kinesis, you could have MSK. Again, the choice of service depends on your organization's standards and what you're familiar with, and the kind of technology that you want to align as an organization. Firstly, I'll talk about ingestion from Aurora. So we have product data, supplier data, all of this data in various Aurora databases. The customer wants to consolidate all of this data into Redshift and have a comprehensive view across different business units, so you can use this data for making decisions. So before zero ETL integration, they had to run a lot of custom pipelines as well as maintain custom code to get the data from Aurora into Redshift. That was a lot of operational burden. Now with the zero ETL integration, they don't have to worry about maintaining pipelines or code for getting this data. With a few clicks, they can set up this integration, and then the integration takes care of replicating the data from Aurora to Redshift. And they have gained like significant operational benefits as well as reduced their SLAs to seconds as opposed to before. Let's look at some key strategies here. So again, the first one is be aware of all the zero ETL integrations that we are adding. If you have a zero ETL integration service, then probably it might fit your needs. So you don't have to take that operational burden, leverage this service. And we keep adding new integrations as we see based on the feedback that we get from you guys. And then control the frequency of replication. So there's a refresh interval that you can control. So that basically helps you with the latency. Based on your business requirements, you can control that latency as well. So you can get the data based on what you need. You don't have to constantly keep running this pipeline as well. That way you don't burden your downstream or upstream systems. Next, let's talk about autocopy. So this retailer gets a lot of data from sales log transactions or transaction logs, all of them in different S3 buckets at different intervals of time. Before S3 autocopy, they had to get this data, write custom workflows, maintain those jobs to get the data, ingest that into Redshift. They had to maintain all of those pipelines. But now with the continuous integration, a continuous autocopy that is available, the data team doesn't have to worry about integrations anymore. They just have to set this up once, and then the system takes care of copying the data over into Redshift. Next, let's talk about batch ingestion. This is probably the most common ingestion type that we have seen so far. And this is again multiple data that is coming in from point of sale systems or web application sales. This is a lot of data that needs to be transformed, enriched, data quality checked before it can get into the data lake for downstream consumption. So AWS Glue is the most popular choice that we have seen here, and you can use Glue for meeting these requirements. And there are other services like EMR or DMS that can be used depending upon the specific use case, or a combination of all of these might work as well. Let's look at some key strategies for AWS Glue. So when using Glue to get the best performance out of your job, there's different worker types that it offers. So even in the standard worker types, there's different versions of it with G1, G2. Each of them gives you different vCPUs and memory. So based on your job performance requirements, choose the right instance, and also enable auto scaling. So if you have varied workloads, it can scale up and down based on your requirements. That way you get the best performance out of your job. And we also have something called as a flex type, which is basically the spare capacity in Glue. If you have like time insensitive jobs that you're running to batch fill with some data or something like that, use the flex type of worker. That way you can get it at a lower cost, and you are still meeting your SLAs as well. And of course, we always recommend to use the latest version of Glue, because we always have some performance improvements over the previous version. So having the latest version, you get the benefits of that performance improvement over open source Spark out of the box. And then Glue also offers a number of job metrics, and it also gives you access to the Spark UI. And you can do real-time monitoring to get to monitor your job, so you get the best performance for your job. And we recently also added generative AI Spark debugging for any kind of root cause analysis of Spark errors in Glue. So that gives you an insight, and it also gives you some recommendations, so you can enable those recommendations to get the performance from your job as well. So make sure to use all those features that we have. Next, let's talk about streaming analytics. Again, here there's a lot of clickstream data that's flowing into Kinesis data streams. So there's two parts to the streaming. One is the ingestion into the stream storage itself, and then there's a consumption from that stream storage. So I'll talk about that ingestion part in a bit, but let's talk about consumption from stream storage. So you can, once the data is in Kinesis data streams, there's multiple ways to get it into the data lake or other downstream systems. So you can use managed Flink if you have like really complex event processing, business logic that you need to run. Then you can consume the data using Flink and get it either into another stream or some other downstream systems like time stream or the data lake as well, depending upon your use case. And if you don't want to have any of that overhead, where you don't want to maintain any code and you're just looking for a data transfer from the stream to the data lake, there's Data Firehose that you can use. Let's talk about some key strategies for this aspect as well. So first, Kinesis data streams. So Kinesis data streams is charged based upon the amount of data that you ingest and then the amount of data that you retrieve from the stream. So definitely we recommend that you aggregate and compress the data as you're putting it into your stream, so you minimize the costs there. And there's a Kinesis producer library, and which basically comes in with APIs that help you aggregate, compress. It also has capabilities to bash the data, as well as a built-in retry mechanism. So leverage those APIs, so you're not reinventing the wheel here. And similarly, on the consumer side, it can deaggregate and read the data and retry if there's any issues. So use those libraries to your benefit. And if you have multiple consumers, there's something called as enhanced fan-out that you can enable on Kinesis data streams. That way you can get the performance, or for the shards that Rahul mentioned, you can get throughput for each consumer, like 2 MB per second for each consumer. That way you don't have consumers struggling to get data out of the stream. And most customers that I have seen typically start off with on-demand, where we provision the throughput for you. And if that doesn't meet your requirements, we scale it up and down. But if that doesn't meet your requirements, then move to the provision mode. Next, talking about Amazon MSK. So again, this Kafka cluster is built with all the brokers. So we have a different variety of brokers here. There's the standard brokers which come with some CPU and storage that it comes with. In addition to that, we recently released express brokers which scale for a lot of throughput. So if you have high throughput requirements, make sure to use the express brokers because they give you a scalable throughput. And then you can use scale, and the express brokers also have they can recover faster from any failure. So you get the best performance out of your cluster. Again, based on your requirements, choose that right broker to meet your requirements. And once you have the system set up, do watch out for the CloudWatch metrics that MSK provides a lot of them to monitor the CPU usage, especially because it's a distributed system. There's a lot of things going on. So we want you to make sure that the CPU is about 60%. So the cluster has things for other operational things that it does. And we also have storage metrics that you can monitor if you're not using the express brokers. You can have auto scaling in storage where it will scale up for your storage as well when your cluster is getting full. Moving on to Flink. So Flink is a fully managed service that gives you where you can code with Java, Scala, Python or SQL to process and analyze the data. And you can run different kind of jobs for continuous running, or if you have to do interactive analytics, you can use Flink as well. But when you're running, it's a completely managed service, but there's some operational things that you can do to get the best out of the Flink application. So if you want you to implement fault tolerance, you can do that by enabling checkpoints and snapshots so you can recover from a point of time in case of any failure of the application. And there's a parameter called parallelism in Flink that you can control. So that parallelism is what gives you the throughput in Flink. So depending upon your job requirements, you can either give the parallelism at the job level or at the operator level. If you're running some intense operations, maybe those need more parallelism. So make sure to use that so you don't have to pay for the costs unnecessarily. And Flink comes with a lot of connectors. So, and each Flink version has newer versions of connectors that we support. Make sure to use the right dependencies with each Flink version that you're using. Otherwise, you can potentially run into some unforeseen issues with data inconsistencies or runtime challenges as well. So make a note of those. And then for Kinesis Data Firehose, this is a fully managed service, but it does provide you some insights into or some hooks where you can batch and buffer the data, where you can wait for some time before sending the data to your downstream system, or you can wait for a specific size before it comes to the downstream systems. So make sure that you're using those so you don't overwhelm your downstream systems. And then you can also implement error handling strategies where you can divert the error records into a separate location. So you can take a look at those records later on for any kind of processing or to identify what went wrong. Next, we have the Amazon Zero ETL integration. So this one was a brand new release that came out, this reInvent. So for this customer, they have some chat conversations in Salesforce that they want to get into the Lakehouse. So now they can use this Zero ETL integration so they can get the data without having to worry about the underlying connectors or the APIs. We maintain all of that for you, and we are able to tune it, scale it based upon your throughput requirements. Before this, you had to write all these custom ETL pipelines, identify the connector. All that overhead is taken away for you. And then we have Open Search Ingestion. So here, this retail customer has a number of logs coming in from various web servers and applications that they are capturing and putting into OpenSearch for OpenSearch analytics. So before OpenSearch ingestion, they had to run these ingestion pipelines on EC2 instances. So they had to maintain not only those EC2 instances, but they had to control the code on that EC2 instances for those custom ingestion pipelines. So they needed like a CI/CD cycle and then patching of that EC2 instances and scaling and monitoring those pipelines before the data got to OpenSearch. With OpenSearch ingestion, now all that maintenance, all that operational overhead is gone now. They just have to worry about setting up the ingestion pipeline, using the transformations based on their requirements, and then let OpenSearch scale based on your requirements. So OpenSearch scales up and down, so they don't have to worry about scaling this. Some key strategies for OpenSearch ingestion. So because it is based on a VPC-based service, ensure that you have it across multiple availability zones. So you have high availability. In case of any availability zone going down, you still don't lose your OpenSearch pipeline. And then you can always configure a dead letter queue. That way you can have some error hardening. If there's any errors, all the error records are sent into that dead letter queue. So you can use that data for any kind of debugging later. And OpenSearch is able to dynamically map the data types for the input data to what OpenSearch index can have. But if you have specific requirements for a search, you map those data terms yourself. That way you get the best benefit of the search. Your search is optimal. And then you also have the option to propagate only some of the required fields. So you don't have to send everything that's there in an S3 file into OpenSearch. So you can do selective filtering, any kind of S3 selects as well before you send the data to OpenSearch. So that wraps up our data ingestion architecture, where we explored through various different methods of ingestion. And then we have an architecture which is using managed capabilities as well as zero ETL integrations, letting you do efficient data ingestions at scale. So just to recap, we talked about data ingestion into the data warehouse, data lake, Lakehouse, and log and search analytics engines. And we also talked about some key strategies on how to use these ingestion services to design a well-architected system which is reliable, robust, as well as cost-effective. So to conclude, here are some links where you can learn more. And I hope you can use all of these different ingestion services and their key strategies to build a system that is automated, scalable, and has a lot of zero integration pipelines as well. We really appreciate you coming to our session, taking the time to attend it. And please do take the session survey and talk to us if there are any other questions post this session. Thank you.